us try this example. You are asked to determine the power series of tangent x as far as the term x power of 3. To solve these questions, first you take f(x) equals to tangent x. You will need to differentiate this function several times until you reach to the term x power of 3. From the formulas of the Maclaurin series, x power of 3 term will be together with the differentiations of the functions to the third level. Therefore, your differentiation shall reach to the third level. Now you need to differentiate this to the first level. Tangent x after differentiations will give you secant square x. This is obtained based on the formulas from the differentiations. Your next differentiations, it will be secant square x. From the list of the formulas, you are unable to differentiate directly for the secant square x. However, you are able to differentiate secant x. With that, set this as a y here and let u equals to secant x. Differentiating u over dx will give you this as per the formulas given in the tables. Substitute u equals to secant x into the function here, you will get y equals to u squared. Differentiating this over du, you get 2u. Based on the formulas of functions within functions, dy du, du dx. Substitute u equals to secant x into the formula here, you will get this. Rearrange it, you get dy dx equals to secant square x tangent x. Next, you need to differentiate this to the third level. This is the product relationships. You will need to solve it by using the products rule. Let u equals to 2 secant square x and the remaining, which is tangent x, equals to v. Differentiate both u and v, you get du dx and dv dx. Differentiations of secant square x has already been derived in the previous calculation steps. You may straight away adopt the solution here. To be multiplied with 2 here, you get 4. And differentiating tangent x, you get secant square x. This is the formulas for the product rule. U dv dx plus v du dx. Rearrange the solutions, you will get the differentiated outcome to be this. This will be the solutions for the third level differentiations. Your next step now is to substitute 0 into the functions derived here, which will give you the final solutions of 0, 1, 0, and 2. Based on the numbers which you have generated, substitute them into the Maclaurin formula. And this will give you this. And after simplifications, your power series will be this, which stops at the term of x power of 3. Let us try this example. We are asked to expand long 1 plus x for the phi term. The phi term here means the phi term after the expansions, which is 1, 2, 3, 4, and 5. With that, you will start to differentiating the functions fx equals to long 1 plus x. You may straight away substitute 0 into the function here, which gives you 0. You will differentiate levels by levels and substitute the relevant value. You are looking for 5 terms, and the first term will give you 0. It means you will have to differentiate until situations where you have 5 numbers. That will lead to you to stop at the 5th level differentiations. Substitute the value here into the Maclaurin's formulas. Rearrange it, you will get the series. And this will be your final answer. The next questions ask you to expand ln 1 minus x to the 5th terms. Since that we have done the ln 1 plus x for the 5th terms in the previous example, and the outcome are obtained here, you may simply replace the 1 plus s to 1 negative x. Substitute the negative x to replace here. That means the x here are to be replaced with negative x. The square of negative s will not convert the plus and minus sign. However, when you encounter the odd number, the positive sign will become negative. Same goes to the 5th terms. The positive sign will become negative. With that, you are able to obtain the solution here. Of course, you can derive the solutions without referring to the previous example. That means you have to go through a series of calculations for you to adopt x equals to 0, adopt the formula, and for you to expand the series. You can try this yourself. The outcome should be this. Let us try another example. Now you are asked to determine the power series of ln 1 plus x divided by 1 minus x. If you expand this, you will get ln 1 plus s minus ln 1 minus x. Based on the previous example, actually you have already derived the ln 1 plus x and ln 1 minus x. The derived outcomes are here. With that, you can actually adopt the series here by having the ln 1 plus x to be minus with ln 1 minus x. Open the bracket and solve the solutions. This will be your final solution.